Now we are starting with second part of this chapter, that is the techniques of separation of mixtures. The few properties which we come across while taking the separation techniques into account are solubility of the components, boiling point of the components forming mixture, freezing point, then sublimable nature and the magnetic properties. Now when we are talking about separation techniques, we will come across following separation techniques in this chapter: evaporation, centrifugation, separating funnel, sublimation, chromatography, distillation and fractional distillation, and magnetic separation. The very first technique, that is evaporation, involves the principle that is, it is actually able to separate a volatile component from the non-volatile component of the mixture. And here we are seeing the diagram, the procedure is shown. In this case, we are separating actually the ink which is present along with water. So here the ink is the non-volatile component and water is the volatile component. Water will volatilize and ink will be left in the washed glass after heating. And you see there we are using a water bath for heating ink, because otherwise there are chances that the components of ink may undergo decomposition if we heat them directly on the flame. Next technique is centrifugation. It is actually done physically in earlier days, but now it is done by machines which is called as centrifuge machine. And the basic principle which is involved in centrifugation is that we are able to separate the heavier and the lighter particles, that is the denser particles from the lighter particles by means of centrifugation. And it is basically used for separation of cream from milk and the components of blood, and then drying of clothes in washing machine dryer and all, we use the same technique. Then we come across these figures. You see in these figures they have shown us how we can separate the different components of blood like serum, RBC, etc. And you see the denser particles at the bottom, that is the solid particles, erythrocytes, granulocytes at the bottom, and if you see the lighter particles at the top. Now next technique is separating funnel, which is actually used for separation of two liquids which do not mix with each other, that is the immiscible liquids it is used for. And this is basically again based on density only, that we are able to get the two components in two different layers, that is heavier layer and lighter layer, the heavier component at the bottom and the lighter component at the top, as you are seeing in the figures shown here. The component with lower density at the top and the component with higher density at the bottom. You can see the example here: kerosene oil and water separation, kerosene oil being denser at the top and water comparatively lighter at the bottom. Then next we have the technique sublimation, which is actually involving the principle that in the mixture one of the component is sublimable and the other component is non-sublimable. So what actually happens, the sublimable component changes into vapors and get deposited on the inner cooler parts of the apparatus, and the volatile component is actually the sublimable component, and the other component which is retained in the reaction mixture flask is the one which was non-sublimable. Here you can see in the figure also, it is very well shown here that we have taken the mixture and we are able to see on the inner walls of the funnel the component which is sublimable first changing to vapors, then on cooling getting deposited there, and the component which is non-sublimable is retained back. Like in this case we have shown separation of ammonium chloride and sodium chloride. Ammonium chloride being sublimable will change to vapors and finally solidify, and sodium chloride is retained back. Then the other technique is chromatography. This is actually the technique which is used for separation of colored components. For example, colored components present in ink can be separated by this process, and this technique is actually based on the principle that we are able to separate the component because of the reason that they have different solubility in the solvent. One which has more solubility will be rising more in the filter paper, and one which has less solubility will be rising to less length on the paper, that is the chromatography paper which you are using. So this is actually the technique is based on the solubility of the components which are present in the mixture in a solvent. Then when we say the examples, if we look at there are samples of ink which can be separated by this process, then we can separate the pigments present in chlorophyll. Then we can separate proteins and amino acids by this process. Similarly, colored components in ink. Here is the example shown by means of figure, the chromatograph shown here, that is the chromatograph paper, is the paper on which actually we are allowing the components to rise. Then we have distillation, which is actually a technique based on separation of liquid mixtures, and the principle involved here is that the two components should differ in their boiling points by at least 25 degrees centigrade. What we are actually doing here is that we are just heating the liquid mixture. The components which it will be having will have different boiling points. Suppose two components are there, they both will have different boiling points, therefore they will vaporize at different temperatures, and one which has lower boiling point will be vaporizing first and the vapors can be cooled and collected, and the other component which is higher by boiling point will be vaporizing later and the vapors can be collected at a different temperature. But the essential requirement is that there should be a difference in boiling point of at least 25 degrees centigrade, otherwise the two vapors will mix with each other and we are not able to have clear-cut separation of the components. It is used for separation of mixtures of acetone and water, and both have different boiling points, so we can separate them by this process. Then we have the diagram which is shown here for distillation. The diagrammatic setup shows how we are maintaining the temperature, and to have an eye on temperature we have placed a thermometer also. Then we have the condenser for cooling the vapors which are formed. Then we have the receiving flask for collecting the components separately. Now another technique which is more important than distillation is fractional distillation, because this technique is required actually for separation of the components of the mixture when there is a difference of less than 25 degrees centigrade between the two components of liquid mixture. The only addition which we are doing in this way, technique is that we are using a fractionating column which is actually creating hindrance for the components of the two vapors which are present in the mixture, that is the vapors of the two components. We are creating a hindrance so that they reach the condenser after some time, so that we get enough time, enough gap between the two components to reach the condenser and we can collect them separately. So this fractionating column is just inserted to hinder the vapors from reaching the condensers fast. So when there will be a delay in reaching of the two component vapors in the condenser, we can easily separate them. This is the diagrammatic apparatus shown. Here you can see the fractionating column being added, which is actually hindering the vapors from reaching the condenser fast. Then we have magnetic separation, which is actually separating the mixtures which have one of the component as iron, which is magnetic in nature. So we can separate by this method mixture of iron and sulfur. Iron will cling to the magnet which is passed through the mixture, and the sulfur particles will be left behind. So for this technique, essential requirement is that one of the components should be iron. Thank you.